Hello, everyone. My name is Henry Zhang. I'm a product manager of Amazon Web Services, Amazon Glacier. So today I want to share a little bit about Amazon Glacier as a long-term storage service that we offer commercially, on how customers use that. But before I start, I just want to thank the committee, thank Slack for having me here. I was a student at Stanford more than 10 years ago, and I remember the time when being here, being surrounded by really smart people. It was a very inspirational and humbling experience at the time. I think today I walk into this auditorium, I get the same feeling. There are a lot of smart people here, so I feel really honored to share some of this information with you. And I encourage you to ask a lot of questions. Feel free to interrupt me because this is the last session before we get lunch break. So I want to make this very casual. So Glacier is the archival storage service offered in Amazon Web Services. And before I dig into the technicality and the features, I just want to share with you first how customers are using Glacier, how customers are building archive applications with infrastructure services provided by Amazon Web Services. So SoundCloud is a social media platform for audio. If you play guitar, if you like to sing, you can upload a clip that you record. You can share with your friends. They can comment on how your lick sounds, how's the timing on your singing and things like that. And SoundCloud archives the raw audio footage in Glacier, and it's already storing multiple petabytes today. And they intend to keep that data forever. So similar to audio, in the video archiving space, we have solutions like Sony DADC, which is a post-production service that Sony's new media division launched in January. So what they're doing is, if you watch movies, like Technicolor, Deluxe, those are the post-production houses that are very CapEx heavy. They run the post-production of movies. So anytime after the camera shot is done, there's a process that does editing, that does captions, that does rights management, that does delivery to different regions. And Sony DADC is offering this as a service in the cloud. So any creative personnel that want to shoot a movie but don't have the budget to work with a large post-production house can use the service to create movies and deliver it to the audience on their cell phones. So very interesting use case. And part of their use of Amazon Web Services is that they are storing original video archives that Sony has collected in the last 30 years. And it's in multiple petabyte scale range, and they plan to archive that data forever. So in the healthcare space, we see very similar trends. There is a huge need for preserving data for the long term. Customers care about durability, customers care about the accessibility and the low cost. So Philips Healthcare supports over 1,500 hospitals in the US, and they collect many petabytes of medical images on a daily basis, and they archive that in the Amazon platform, storing that in Glacier. And the thing to know here is, for healthcare customers, they care about this thing called HIPAA, which is the health information. So health information, personal information cannot be shared, and a service provider has to meet these rules before Philips or GE can use that platform. So they found that capability very helpful. That's provided across many Amazon Web Services capabilities. So last but not least, this is a public sector use case from King County. This is where I live. I live in Seattle, and King County is the largest county in Seattle, the Washington state. So King County used to back up their corporate data on tapes, and they've been doing that for many years. But 2 years ago, they switched to Glacier and completely got rid of their tape solutions. And within the first year, they were able to save $1 million. In addition to saving them money, they have seen much better operational agility. For example, they don't have to refresh their tapes anymore. It was one of the things that was a big pain for whoever who had to do it, because if you get this right, you hardly get a pat on the back. Someone won't say good job, but if you get it wrong, you'll be losing data, and you'll be responsible. So they found that getting rid of this operational churn is very helpful, and they have more cash flow to invest in other projects that can benefit the state and the community. So having shown you some of these examples, I think what we see in the last couple of years is that data archiving is really becoming a big necessity, in part due to the growth of the explosion, I would say, of large data formats. You look across all of these industries. Media, for example, the assets are turning into 4K format, 8K format. Cameras are getting bigger. They're getting higher resolution. A couple of years ago, we had 1 megabyte per frame in a high resolution camera. Now it's 10 megabytes. And I think nothing probably is going to exceed the LSST telescope camera, which is the largest in the world with 3.2 gigabits of pixels. I can't do the math of how large a single shot will be, but Jacek just told me that in the next 10 years, it's going to collect 50 petabytes of data. That is a lot of storage. So we see growth in all of these industries. I think geospatial is a huge industry. I think it's also triggered by the ability, the tools that we have to analyze large amounts of unstructured data, right, in a very fast way, economical way. I think before Hadoop, it's very hard to do. Now we have multiple tools that can run this in a distributed fashion. So I think there's more business needs to preserve more data because many customers and companies are treating that as a competitive advantage. The more data that I have, the more opportunity I provide my organization to extract insights and compete in the industry. So how have customers done this in the past? I think archiving is primarily realized by using tape solutions or nearline sort of like low performance disk solutions. So far, tape is still the dominant solution in the market. I think my previous speaker mentioned they were on Oracle storage technology, migrating from B to C to D. And we continue to see that. I work with customers that migrate from tapes every day, and many of them are working with us to stop that migration, to do a one last time migration onto Amazon Glacier so that they don't have to do migrations anymore. I think a couple of the things that customers really dread is doing this operational churn. It's not a value-added thing. And just think about the resource that you can get out of not doing this operational management and how you can put that into doing other creative workflows that generates more value for your customers, for the community. So from Amazon's perspective, we want to help customers on several fronts. Number one is we want customers to think about not owning your infrastructure. I think every large organization that has a big data project like the LSST are thinking about, hey, when do I budget? How do I budget? When do I build out my data center? How many millions of dollars is it going to be to buy the next set of servers and storage farms and things like that? Not only is that a big CapEx investment, it also takes time to install those. It's typically a 6-month end-to-end cycle from getting approval on budget to getting your storage and compute platforms ready to go. That's a very long time. I think the customer would really love to shorten. What if I can start running something within a day? And that is something you can do on Amazon Web Services. I'll give you one example. In several large European media customers, broadcasters, are experimenting with doing channels, live broadcast channels in the Middle East, in Eastern Europe, which are traditionally the under-penetrated space for broadcast. They want to test, is there a market to run a new live channel in these regions? But it's very cost prohibitive. It's $100,000 to get all the equipment in place before you can do a live broadcast. Now, many of them are looking at cloud solutions to do a test project, which within a month they can find out if there's a market, and the cost of that is under $10,000. So the agility and the flexibility that we can get by using virtual infrastructure from cloud providers, I think, is really what we believe is the trend going forward. The second piece that customers really like is the pay-as-you-go model. So think about buying a data center, buying your tape drives and things like that for long-term retention. It's a very CapEx-heavy model, whereas if you switch to a cloud model and you only pay for the storage that you use, and we actually bill by the day. So that gives you a lot of cash flow enhancement that you can use for other more exciting projects. I already talked about alleviating the churn of operational management of tape migration and things like that. But I also want to highlight the last piece, which is being able to choose where you keep your data. I think several speakers talked about European directives about digital preservation. I think we see more of these trends growing globally. And from Amazon's perspective, we want to give customers options. So we have deployed, as of now, 12 data centers in the world. And we let customers pick whichever location that you need to store your data. So a couple years ago, German customers told us that there is a very stringent law that the business data cannot leave Germany, right? So cloud was, or AWS was a non-starter for them because of that. So a year ago, we launched data center in Germany so all the German customers can keep their data safe and honor the data sovereignty. So in a sense, we kind of want customers to think about the Amazon infrastructure as your global data center that you don't have to build, you just pay for what you need to use. So let me tell you a little bit more about Amazon Glacier. It's our low-cost storage platform, specifically designed for archival storage, for keeping data for decades, if not indefinitely. So we designed the platform with that in mind. It's really meant for long-term retention. So just a quick note on the pricing. It costs 0.7 cents per gigabyte per month. It's all pay-as-you-go. There's no initial investment. So think about storing 1 terabyte per month is $70. $7. Thank you. $7 to store a terabyte a month. And with that, $7, you get redundancy. We store your data in multiple locations. So I talked to a lot of tape customers. I asked them, what is your durability? They tell me they store 2 copies of tape across 2 buildings that's either across the street or 2 buildings that's across 2 zip codes. Let's say they have 2 facilities. With Amazon Glacier, we store your data across multiple facilities, which you can think of as these buildings, and we do replication and durability check. That's all built into this 0.7 cent per gigabyte cost. So right now, a lot of customers use Glacier as a cold archival solution. So I think it's very comparable to an offsite tape backup solution, because getting data out of Glacier takes about 3 to 5 hours. It's actually faster than retrieving data from, say, like an Iron Mountain solution, which you have to recall data, and it takes about a day or 2 days to fetch your tapes. So many customers find this offsite use case, offsite tape replacement with Glacier very appropriate. And I already mentioned what are the most applicable data sets. High resolution media assets, totally applicable, like the telescope images, geospatial data. Financial records is also very applicable because there is long-term retention regulations, at least in the US and in many parts of the world, about keeping transaction data for many years. And then medical images, such as the PACS imaging data, also needs to be preserved for a long time. So we try to help customers solve your data archival needs in many different aspects. We already talked about the low price. We talked about the no need to buy your own hardware. We also talked about the infinite scale. You can just grow on Amazon Glacier as much as you need. There's really no limitation. I want to double click into this durability a lot because for long-term digital preservation, it's a very important topic. So I've talked to media customers in Hollywood. I've talked to digital preservation companies in Utah. And then what comes out is this word called fixity. Fixity is this thing that archive technologists use for truly long-term digital preservation. It really is a fancy word of saying durability, but it means that the data that I stored hasn't changed. It hasn't been altered. So how we do this at Amazon is we kind of measure this fixity and the durability in numbers of nines. This is 11 numbers of nines. It's a very large number. But we also see that customers tend to think about durability in terms of copies. So how do I bridge that conversation? So one time, we talked to a very large studio in Hollywood. You probably have seen their movies. So we share with them how we derived 11 nines for Glacier and S3, which is our more active storage. So we use a Markov chain model. And we model failure rates for the storage devices, for the server, for the network, for the building failures, and then for the entire geographic region failure. So we plug in a bunch of these assumptions. We run the Markov chain simulation. And then we came out with this 11 numbers of nines. So to bridge the conversation with copies, we asked this storage architect at the Hollywood studio to say, hey, could you use the similar model to estimate durability for 2 copies on the same site or 2 copies across two locations? And a couple of days after, he came back and said, the 2 copies on the same location, he estimates that to be 4 nines of durability. 2 copies across, say, 20 miles, 2 buildings, he estimated that to be 5 numbers of nines. So that was an aha moment for him and for us because we realized at that point that our durability, Glacier's durability, is actually 7 orders of magnitude higher than 2 copies of tape. That was a little astonishing. So I think once we got through that piece, right, it became a lot easier to get customers to think about, here are my numbers of copies, here's the durability with Amazon storage services. And they really started to tie things together very quickly. So going a little bit into the product specifics, a couple of key concepts. How do I use Glacier? So it's very simple. You create an account with Amazon Web Services, and then you create containers, which we call vaults. Vaults are these folder structure that you can store lots of archives, where each archive is just a collection of bytes. It could be a high-resolution image. It could be a log file. It could be a tarball of a bunch of log files. It could be a video. An individual archive can be as big as 40 terabytes, and I think that's a pretty large number. But there's no limitation on the number of archives you can store in a vault or in your account. So in essence, you can store unlimited amounts of data with Amazon Glacier and continue to just pay for what you use. From the indexing perspective, we made a very conscious decision to not provide a live index. This allows us to reduce the cost to the number that we can offer you. Had we would have offered a hot index that you can do queries and search and all that, but we decided not to, and then customers actually find that very flexible because they can now attach a database that registers the archive ID, and then they can do very rich indexing on top of this cold storage platform. There's a number of things you can do. You can put index in MySQL, in DynamoDB, or whatever you choose. So for those of you who are looking to build applications, there are several ways of using Amazon Glacier for your application. So obviously, for the programmers, you can use the Glacier API, SDK. We offer a Java.NET based APIs. Very simple to use, and the same SDK applies to all of the Amazon Web Services. Or you can use this lifecycle integration, which ties together our active storage S3 with Glacier, which I'll show you in a minute. And the last piece is for those of you who may have come from an IT admin background and prefer to use third-party tools or software that hides, that abstracts this program interface. So there are ways to do that as well with third-party tools and gateway. So let's dive into the programming model a little bit. I'll just highlight this. So with APIs, you can create a vault. That's your container. And then what we recommend is you configure a set of access policies on the vault. This is a piece where we think Glacier is a managed archival service instead of just tape solutions where you buy the tapes and then you have to configure the security and do application level controls and AD and things like that. With Amazon Glacier, you can configure policies on your containers to say who can access this vault at what time, from what IP address, and things like that. Once you have that container configured, you can use our APIs to upload archives. On the confirmation that your data has been stored durably across multiple buildings in our data center, we give you a HTTP 200 that signals that this piece of data is now reliably stored. One thing to note that is during the transmission phase, we request a hash value that you send to us to prevent bit flips on the wire. And then we store that hash value. It's MD5-based hash. We store the hash value with your data. So we can do integrity check on a rolling basis by comparing the hash to the data. Let's say we detect some portions of the data that may have been corrupted. Then we'll quickly resolve that by using the duplicate copies to restore that data. And we do that by checking against the hash value that we store on receipt of your data. So on the way out, retrieving data from Glacier is a two-step process because there is a 3 to 5 hour access latency. Asynchronous programming model for those of you who are interested. You initiate a retrieval job where you tell us the archive ID. And then we'll take about 3 to 5 hours to prep your data. We'll take it out of the cold storage. We make it readily accessible. We place it on a staging location. And then we send you a notification. That is when you can go to the staging location and pick up that data. You can download it to your laptop, or you can use it in the Amazon platform on EC2. Fairly straightforward. So a couple quick notes on the third-party tools where, for those of you who are looking not to write programs. So there are several types of tools that are integrated with Glacier today. There are the consumer-grade tools that customers use to back up their computers. Cloudberry, Fast Glacier on the Mac OS. There's Arc. Many customers back up their laptops or the photos on the laptop for the pictures onto Glacier. And some of those tools are free, but most of them are under $50, right? And those tools, like Cloudberry, give you a UI interface that you can still drag and drop files into Glacier, and you wouldn't even know that there's an API model behind it. It abstracts everything for you. And then for small and medium business, typically they use a small NAS for back office. For satellite office, they have several NAS deployments, and then that synchronizes to a central location. There are entry-level NAS products, hardware solutions that are $500 to $1,000, sometimes a couple $1,000. That's integrated with Glacier. Synology, Veeam, QNAP are all good options to get started to play with the platform. And last but not least, for those enterprise customers who are looking to manage multiple petabytes of content in the cloud, they will typically resort to a enterprise-grade storage gateway. So Philips, in this case, they use a NetApp UltraVault that bridges their on-premises solution to the cloud, which also abstracts the API interface. So just to give you an example, for those of you who have run backup solutions, Commvault Sympana has tight integration with Glacier and S3, so you can basically use the AWS storage options without even knowing that you're doing that. They will be presented as a storage location in Sympana, and you can carry on with your backup archive workflows by just changing the new storage location. So I've talked about Glacier, and I also mentioned S3 a couple of times. So let me give you the fuller picture of the storage portfolio and how sort of working them together can give you more benefit. So across the portfolio of object storage on AWS, we have 3 products. On the left, there's S3 Standard. It's the active storage for the internet. Almost any web company is using S3 today. When they get started, this is the quickest way to launch a project, to test the market and things like that. On the right-hand side, we already talked about Glacier. It's our cold storage. It takes about 4 hours to access. And then in the middle, there's this infrequent access for S3. It's a variation of S3, and I think about those as your Facebook pictures That is your one day old Facebook pictures. You may get occasional clicks, but they're not as hot as the first hour that you posted them. And naturally, we see this trend going across these three options. The more active the data, the more appropriate it is to put it in S3. But then as the data gets colder, we want to push the data to the right, so then we can lower the cost by using these storage options in tandem. So to support that, we offer a data lifecycle management tool, which is really a tiering facilitator that allows you to tier data from hot to warm to cold. So you can transition data from S3 standard to the infrequent access layer. You can then transition that into Glacier, all via policy. And then you can also set an expiration date to say delete everything after a year. So let me just show you an example. All of this can be done very easily in a UI. Let's suppose I have videos that I push into S3 standard initially. Those are hot videos that I need to do editing, that I need to share, that I need to do a bunch of processing. Those could be like the high resolution pictures that I get from LSST the first night. I have to do a lot of processing. But then, after the next 30 days, I don't see much processing going on, so they get colder. That's a good opportunity to push that into the infrequent access storage, which is still immediately accessible, but you get a lower cost. Then after about a year, you'll say, okay, I don't see any processing or very minimal processing on the data. It's really aged. Now let me push that into Glacier. And all of those can be done with a single descriptive policy. So you get a lot of savings by using these three storage options in tandem. By switching from the hot to the warm tier, you save 58%. And then by switching from the warm to the cold tier, you save another 44%. So customers really find using this entire portfolio to optimize storage cost very attractive. But the key here is that you know the characteristics, the access patterns of your data. You will design these patterns for when to transition or whatnot. So one more thing I want to share with you is how we sort of view data preservation alongside compliance. So at Amazon, we work with a lot of financial customers, a lot of regulated customers, utilities, government, pub sector. There are rules. There are regulatory rules to retain data for decades. Sometimes for 7 years, financial services for decades in other industries. And then these customers typically buy, I'll say these tailor-made, purpose-built storage arrays that is warm. I think one of the speakers mentioned warm as a flavor of the MongoDB engine. I think warm is still a necessary use case in many of these regulated industries. So the cost of these regulated compliance storages is pretty high. It's not the easiest to operate, so we want to make that simpler for customers. So last year, we launched this new capability called Glacier Vault Lock. Essentially, you can turn Glacier into compliance storage within a couple of minutes and then meet your compliance goals. So what does it do? The most popular use case for warm is time-based retention. I have to retain financial records per SEC by 7 years. Or for pharmaceutical companies, I have to implement an access control so that my top secret drug formula cannot be accessed unless it has validated a three-way authentication. That's a multi-factor authentication. So with Vault Lock, you can devise these compliance regulatory control policies, install them on the Glacier container, and then they will take effect and govern those data for you. And the thing to note here is once you commit to this policy, the policy is no longer editable. So that is how we enforce this very strong governance. We already talked about these. So let me give you a little bit more color to this. So Glacier as is already a non-overwrite content. Once you upload an archive to us, we give you a unique content address. If you upload the same content, we will give you a different content address. There's no way for you to overwrite what you already gave us, right? So the Vault Lock essentially added the capability to make this data non-erasable. So now we become warm. Second part is that to help you control a time-based retention, we created this control code called archive agent days. It essentially measures how long an archive has been stored with Glacier. And based on that, we can compute whether it still needs to be to be retained, or can it be deleted as the data has exited this retention window. The policy I mentioned, the Vault Lock policy, it's a very strong governance mechanism in that once you commit to the policy, you cannot remove that. You also cannot mutate that. So the policy will say all the records, financial records that goes into my financial trading vault needs to be retained for 7 years, needs to be stored for 7 years. I lock the policy, and the policy cannot be changed. Otherwise, if we allowed manipulation on the policy, then it essentially avoids the worm construct. And last but not least, we also support legal holds. For those of you who are not familiar, legal holds are cases where data needs to be retained due to a legal investigation. Those are indefinite retention until the case is resolved. And when a legal hold is in place, it actually overrides the underlying regular retention period. Let's say I have financial records that needs to be retained for 7 years, and tomorrow they exit this retention window. But today I get a subpoena to retain all the data that's retained. So tomorrow I will no longer be able to delete the data, right? So what we provide in terms of this legal hold is that it overrides the underlying retention control. Until you lift the legal hold, then you can delete the data if it's exited the period. So for financial customers, we realize that there is a certain pattern of adoption of evaluating compliance storage. So we worked with a third-party consultant, Cohasset Associates, who has been in this regulatory industry for over 40 years. And they created an assessment that says that Glacier with Vault Lock can be used by the 44,000 US broker-dealers who needs to retain their transaction records, investor communications, and all of that. So we're very excited about that because we're really helping customers reduce one of these churns. This is something that broker-dealers have to do. They're not excited about doing that. They actually want to delete data as soon as they can because they want to reduce the liability. But by giving them a compliance storage option with no extra cost that they can configure in the Glacier console in under 3 minutes, customers love that. So let me just show you an example of a 1-year record retention. What does that look like? So 1-year retention really means that I'm going to prevent, delete, archive operation from anybody, including the super user, the admin, or the payer of this account, when the archive has been stored for less than a year. Right? It really translates to these 3 elements. So now with these 3 translation, our tool helps you convert these sort of inputs into a policy. It's a little hard to read, but it's a 10-line policy that describes a 1-year retention. It basically says the effect is deny. I'm going to deny principal is the AWS user, any user, in this case, star, on the delete archive operation for my business-critical vault. Right? I'm going to reject all deletes from anybody. And the condition being the archive that you're looking to delete has not been stored for a year. Right? Self-descriptive. And customers love this because they can now take, and obviously you have to lock this policy. So once you've locked this policy, customers can now take a snapshot of this, give it to their compliance officer, and then say, hey, this is how I am compliant. Instead of with other commercial solutions, they have to dig through many different controls to show that they're compliant. So it's a very simple, descriptive way. I already mentioned the 2-step locking. I think because this is a database conference, I want to share that we took a very similar model to a transaction model, right? So when you install the policy first, it's like a beginning trend. So everything that you read will be presented as if the transaction has committed, but it hasn't. So you can test this retention policy once you install this initial policy in this in-progress state. You can test it, and if you don't like it, you can just roll back the transaction by deleting this policy, and you can reiterate as many times as you want. And also to ensure that you're actually testing and not just leaving your container in this limbo state and thinking that you have deployed compliance controls, we enforce that the transaction session, the initiate state is only valid for 24 hours by giving you a lock ID. So after 24 hours, we automatically roll back so that and it's no problem. You can come back and reinstall the policy and test it out. Once you're totally happy, then you can commit this policy by locking it down. So we borrowed a page from database. All right, so I'll be very fast. One more minute. So we've talked about S3 Glacier. We talked about how to tie these together with lifecycle management. Now I want to just give you a little bit broader picture about how object storage fits into the Amazon Web Services platform. Because customers come to us not because of just storage. They want to use compute. They want to use databases and things like that, right? So we offer a number of storage options that meets these needs. There's file options, there's block options, and there are the object options. And on top of that, we try to help you with a number of data transfer mechanisms. Think about having 10 petabytes of data that you want to ship to the cloud for a large image analysis, right? Because you don't have that many compute nodes on premises. How do I move 10 petabytes? It's a daunting task. It's kind of hard to think about. So last year we launched this new product. It's a physical product. It's called Snowball. It's a 47-pound. It's like a little server. Anyone can pick it up. That ships on its own. And the model being, we ship you a Snowball device. It has 80 terabytes of capacity. You can take your time to upload your data, pack it up, and then you ship it back to us. Then we will ingest that data into AWS for you, right? So this is very similar to the pods model. For those of you that have moved, they ship you a container, they park it in front of your driveway. You take your time to load up your couch and sofa and TV and all that stuff, and then they pick it up after you're done. So customers love this because many customers have large data sets that want to move to the cloud. They want to get out of their data center, but they don't have bandwidth. And it's actually ridiculous to upgrade bandwidth so that they can get out of their data center. It's like, why do I want to pay more money to do something that I don't want to do, right? So we have a solution now for customers to solve this problem. It's a physical device. If you haven't tried it and you want to move large data sets, I highly encourage you to do this. Snowball has been live for over 6 months. It's already traveled around the world, I say a couple hundred times. Like you add up all the devices and all that stuff. So super exciting. Pricing-wise, it's very attractively priced. For an 80 terabyte usage for one job, you pay $250 plus shipping, and you get 10 days of usage. So if you have a reasonably fast local network, you can copy 80 terabytes onto the device in a day or two. Then you can ship it back to us, and then you can essentially move 80 terabytes into the cloud in under a week. So we did some math. You can transfer a petabyte of data with 13 snowballs in parallel in a week. So that's very exciting. And I'll be happy to tell you that many customers are in the progress of migrating out of their data center using Snowball and being able to pursue their ambitious archival projects on Amazon. So I'll stop here because I'm already over time, and just want to thank you very much for having me here. Go ahead. Yeah, gentleman over there.
The question was how expensive it is to get data out of it, and can you do it on drives? Because many times we may want to move it to a data center that we create later.
That's a good. So the question is, how much is it to get data out of AWS, and then do we do some physical shipment? So moving data out of Amazon is, I think it's about 3 cents per gigabyte. And if you use Snowball, we do have an export option. So let's say you store 50 terabytes in your container. You want to export 25 terabytes of that, right? You can order one Snowball, write the data onto the Snowball, and we'll ship you the Snowball with the data on it. Once you copy it locally, you send us back. So in that case, you pay for the export job, you pay for the shipping, and you also pay for the 3 cents, I think it's 2 or 3 cents per gigabyte for egress. Yeah.
So 2 comments. One, when I first coined the term cold, that was specifically written out to indicate that that is still active, that is still in the primary namespace and is not an archive. And unfortunately, you're switching back and forth between cold and archive, where Glacier is decidedly an archive. You don't have access to that data. It's not in a namespace. I can't query it. I can't use it. So the intermediary that you just said is warm is actually your new cold. And so there's a very big difference. So I'd encourage you to go read the original paper, et cetera. The other would be that Markov models don't work. And they don't work because they don't understand the concept of correlated failure. And in places like AWS, you buy 50 racks at the same time. The guy who was assembling all those hard drives was drunk that day. All of those machines are going to fail the same way. And so Markov models aren't really safe to say 15 nines versus 6, et cetera. So I'd encourage you to look at better modeling.
Okay, so thank you for the feedback. So comment number 1 is about the terminology of cold and warm. And then what is really cold, what is warm, because, and also where we draw the line. So I do want to offer a comment on that, because I think, traditionally people look at cold storage as offsite tape libraries. It's like there's no access to that, or it takes like a day to access. Whereas Glacier, I think, we offer a 4-hour retrieval, which is faster than the offsite tape libraries. And number 2 is that Glacier being part of the cloud platform, you can retrieve the data and then instantly provision compute capacity to act on that data. So in that sense, it's not as cold as the traditional cold data that I pack away, or the film studios put it in like a sand mine and things like that. So I'll give an example of a customer example where they will store original theatrical footage in Glacier because it's the lowest cost. And then every year, they will take out about 20% of that data to a large batch transcoding. This is in anticipation for the new iPhone coming out. So they want the movies to look great on your phone. Right? So I think we are blending the terminology a little bit, because once you use the cloud, the physical sort of distinction kind of dissipates a little bit. And we're really trying to be this warmer, if you will, cold storage. And then we complement that with an active archive solution using S3 infrequent access. So I do agree that the terminology is blending a little bit, but we actually want to be as active as we can, but still give you the lowest cost, right? Because typically more active storage is going to cost more. The second piece about Markov chain, totally appreciate the input. Love to have an offline discussion with you on the modeling and all that. I think I mentioned Markov chain. There's a lot of details about how we actually did that I probably can't share here. But if you have thoughts on recommendations, we'll be happy to chat with that. I think the thing is, we really wanted to get across this durability messaging to many customers, because we understand that betting your petabytes of data on a vendor is a big risk. It's like getting married to someone you barely know, right? For long-term storage, it's really, you're talking about the next 10, 20 years. So we really want to bridge that conversation, and we continue to work on that. So if there's any ideas that can help us do that, get across the message, we'll be happy to incorporate feedback. Thank you.
I have 2 quick questions myself.
Okay. Sure.
One is for data encryption. Do you encrypt the data, or do you rely on the customer to encrypt it for it to be encrypted during transit and at rest?
Great question. So yes, so everything that we store is encrypted server-side by default. And we rotate the keys in the background, so you don't have to. But you can also encrypt the content before sending it to us. So financial customers or healthcare, like Philips healthcare customers, they encrypt everything that leaves their premises, even though we encrypt for them. So we're like, okay, that's totally fine. But we ensure, why we encrypt data is because if we have a rogue operator in our data centers that just steals a storage device and walks out, there's no way that your data will leak. That is the protection that we provide you from sort of the infrastructure operational level. But you can choose encryption on your own.
And the second question is, in terms of retrieving data, if you have a process like this 20% transcoding or something like that, where you know in advance you're going to be running through a bunch of data, do you provide facilities for helping to do that staging of the data, to bring it back and then throw away?
Yeah, that's a great question. So, so about the retrieving, say, 20% of your data, we do a couple of things. So, first of all, we allow you to set a retrieval limit, right? For example, you say every day, every hour, I don't want to pull back more than a terabyte. This is for financial reasons. This is also to prevent runaway scripts and things like that. But also ensures that you are actually able to process the amount of data that you can pull, right? Sometimes people pull more data than they can process. So we don't want that. Number two is on every retrieval request, we send you a notification. So you can determine whether I need all of this data set to do transcoding, or in the transcoding case, you can actually start transcoding whatever comes back. So I can just stage them iteratively. But there are cases where I need all 20% back before I do an EMR analysis. And that is where a little bit more consideration planning needs to go into that.
I was just wondering if there's any integration with workflow systems that would automatically handle the staging and the computing together, or that's all.
I think we provide hooks to each of the steps, but we don't hook the steps to you. That's what we do today. Yeah.
So in your life cycle, you mentioned that you can go S3 down to sort of the less redundant S3 and then down to Glacier. Mm-hmm. And then you have sort of Amazon, Lambda, and other things. And so are there vendors who hook all of this up for you and say, here's a lifecycle solution? Great
question. So, question is, there are other workflow, inline compute, serverless compute like Lambda functions and all that. I didn't want to bring too much of these to the audience because I don't know how much you know about AWS. Didn't want this to sound like just a sales pitch, but. Customers use a lot of Lambda, for example, in the media workflows to tie things together, right? For example, once they restore the data into Glacier, which goes into S3, into an S3 bucket, they can attach a Lambda function that says, hey, trigger a transcoding job with Elemental, and use 2 GPU nodes to do that, right? And once that is done, sends a notification to another S3 bucket that says, okay, the proxies are now done. I can drop those in there, and you can start delivering. So there are Lambda functions that can do these inline compute. There are also simple workflow that can help you tie these together. But the overall model is we don't do all of this for you. We give you tools to stitch those together.
Perhaps I missed it. What storage media are you actually using? Is this stuff going onto tape, or is this stuff going to write onto optical, or?
Yeah, that's a great question. I think you're the third person that asked this in the last 2 days. Very interesting topic. So, we actually don't disclose the underlying storage platform. We use proprietary devices. In a way, for 2 reasons. One is there is the media, and there is how you use the media, right? So from our perspective, we keep evolving the technology. We choose whatever media that's the most durable, that's the lowest cost, and we iterate on the underlying platform, and then we pass back the benefits to customers. Number 2 is because with very smart people who know storage, right, we don't want you to have an assumption on the technology and then build additional assumptions in your applications and things like that. From the customer perspective, Glacier is 11 nines of durability, and it'll only keep getting better. So independent of what storage platform we use in the background, it actually is. It shouldn't be your concern. That's the point.
Okay. Thank you very much.
Okay, great. Thank you.